Hello, class. I'm going to do a recording for Chapter 10, Section 1, the graphing part. Graphing, it's called the Cartesian coordinate system. And so let me go and share my document camera with you. Okay, so for the graphing test, which is test 3, it covers chapter 10, graphing linear equations and inequalities. So if you look at 10.1, the Cartesian coordinate system, this is what we'll start with. And in your workbook, here's some of the vocabulary that you want to spend 15 minutes on your learn. But here's some of the vocabulary that they go over. And they say Descartes, Rene Descartes is a French mathematician, the French philosopher, and he gives credit for the Cartesian coordinate system, which is the rectangular grid that we use to graph lines and plot points. So it says here that Descartes based his system on a relationship between points in a plane and ordered pairs of real numbers. And if the ordered pair xy is called the first coordinate, x is called the first coordinate, and y is called the second coordinate. So these go in alphabetical order, x and then y. In an ordered pair of the form xy, the first coordinate x is called the independent variable, whereas the second coordinate y is called the dependent variable. Okay. And usually when you think of independent variable and dependent variable, usually the x is listed here as an independent variable, and the y is usually listed here as a dependent variable. Okay. The Cartesian coordinate system relates algebraic equations and ordered pairs to geometry. In the system, two numbered lines intersect at right angles and separate the plane into 4 quadrants. The origin, designated by the ordered pair 0, 0, is the point of intersection of 2 lines. The horizontal line is called the horizontal axis or the x-axis. The vertical number line is called the vertical axis or the y-axis. Okay. And so we're going to look at that when we look at the workbook problems. We're going to take a look at that. One-to-one correspondence. So there is a one-to-one correspondence between points in a plane and ordered pairs of row numbers. Okay. Okay, so that's some of the vocabulary that you'll go through and you'll learn, and you should continue that because there's a watch and a work section. Okay, so I have some notes here to share with you. There's some limitations in your Hawk's learning and your system. So this is what this is kind of talking about. When the system asks you to graph a line from scratch, meaning you pick any coordinate and you plug it in to find the other coordinate, then the computer can only recognize integer coordinates. It only made an answer key for integer coordinates. So it can handle like if you let x be 1 and you plug it in to the equation and you end up with y being 2, it can show you that because it made answer keys for integer coordinates. It can handle -1, 8. It will show you 5, -8. But if you plug in 1 and let's say you get this fraction 8/5, they didn't do an answer key for coordinates that end up being fractions or decimals. They didn't. And so what that means, it doesn't mean that your math it doesn't mean that your math is wrong. It just means that you would have to go ahead and try and pick another point until you can end up with a valid coordinate or an ordered pair, right? That has integer coordinates as answers, no fractions or decimals. And that's only when you're asked to graph a line totally from scratch. The system asks you to do that from scratch. Just keep that in mind. There's another note here that to type the parentheses for an ordered pair, let's say you have parentheses x comma y, you want to use the parentheses found in the keypad, not the parentheses found on the keyboard, like the one above the 9 and the one above the 0. Otherwise, the system won't recognize those parentheses in the ordered pair. So you have to use the parentheses from the keypad. That's another notice to let you know about that. Okay. So here I have a little bit of history. So think of the French mathematician, philosopher, and he was also a physiologist, Rene Descartes. He was born on March the 31st back in 1596. And then he passed away on February 11th back in 1650. But he's the founder of the Cartesian coordinate graphs. He taught astronomy to Queen Christina of Sweden. So he was summoned by the Queen to be her personal tutor. And so the story says that she loved to be tutored early in the morning. And so he died kind of at an early age because he got sick during those early tutoring sessions. You know how they had castles and it was cold back then. And supposedly he caught pneumonia from those early sessions and didn't recover. And so he did die of an early age, but he did a lot of work for his time, and he's coined with the Cartesian coordinate plane. Has a little bit of history in case you're a history buff. Okay, now limitations on the system. It says when you graph a line in the Hawkes learning system and the system provides you starting coordinates to substitute into an equation, then the computer can handle, it will accept any improper fraction coordinate, such as -5/2 or any reduced fraction or any integer coordinate. And so just keep that in mind. But the system will not allow you to input decimal coordinates, and it will not allow you to input mixed number coordinates. So just be aware of that. So suppose a system assigns x equals 3 and x equals -2, and you are to find the valid y coordinates for the equation. And suppose they are as follows: 3, -5/2, and let's say you plug in -2 and you get -7/3. Then these are acceptable inputs when the system provides you starting coordinates to plug in, to substitute into the equation. So they say, yeah, we want you to plug in 3, we want you to plug in -2. But it will not allow you to plug in y's, that have decimals. No mixed numbers are allowed as input coordinates. And then the system will plot the resulting point, the ordered pair. It will oftentimes plot it for you, and it will also graph the line for you. But you should think these points through in your mind and trace the plotting of the plot yourself to ensure that you learn how to plot points. I think it does a little bit too much for you because it right away it plots the point and it grabs the line for you. It should let you try and plot the point and connect it with your mouse, but it doesn't do that. So you have to think it through. To type the parentheses for ordered pairs x, y, use the parentheses found in the keypad, not the parentheses found on the keyboard above the keys 9 and 0. Otherwise, the system will not be able to recognize your input. And the system is limited to plotting XY coordinates that range from -10 to 10 on the x-axis and that range from -10 to 10 on the y-axis. So you will not be able to input any ordered pairs that contain coordinates beyond this range. If you randomly try x equals 9 in the equation, and let's say the y coordinate ends up being 17, you will not be allowed to input the ordered pair 9, 17 into the system because of its limitation. It's limited to a 10 by -10. This means that you'll have to randomly pick another x value and try something, maybe smaller, so that you can identify both an x and a y that meets the limitation of -10 to 10. And when the system prompts you to graph a line from scratch, meaning that you pick any coordinates and you plug into the equation to solve for the other coordinate, then the system will only recognize valid integer coordinates for ordered pairs. So for example, the system can handle and will accept such coordinates with integer coordinates like 1, 2, -2, 8, and 5, -7, but the system cannot handle, it's not able to plot in like 3, 3/8 or -8/5, 6. The system is limited to all integer coordinates and its tolerance is low when the system prompts you to graph a line from scratch, meaning that you randomly get to pick any coordinate and plug it into the equation to solve for the other coordinate. You may input only ordered pairs consisting of only integer coordinates. So there's some of the limitations there on your system, okay? Okay, in your graphing test folder in your module, your teacher has created a handout. If you wanted to print this and use this while you're taking the graphing test, that would be okay. So it's got, some formulas that we'll cover and some characteristics of horizontal lines and vertical lines. And then talks about slope intercept form, point slope form, graphing linear inequalities. So this is a helpful form. You can, if you want to print that out, you can. You're also allowed to use, the first sheet or sometimes the first 2 sheets from each section has rules and definitions and steps that we put that you can also use while you're taking the test. But you're going to have this out as well. Okay, so if we look at the problems first that the math department made. The math department made 4 problems and they start on page 158. Why don't we take a look at that first? Okay, so, we talked about this Cartesian coordinate plane, and it's divided into 4 quadrants. So quadrant 1 is right here. Quadrant 2 is right here. They use Roman numeral numbers. This is quadrant 3. And then we have quadrant 4. Okay. And they were talking about the origin. So this is your origin right here. That's 0, 0. And you have an x-axis right here. And you have a y-axis right here. Okay. And so you notice these quadrants go counterclockwise against the movement of the clock. So points either live in a box, in a quadrant, quadrant 1, quadrant 2, 3, or 4, or they live on an axis, the x-axis or the y-axis, okay? And on your signs, any point that lives in quadrant 1, in your, you have an ordered pair x, y, well, the x is positive and the y is positive if it lives in the first quadrant. If the point lives in the second, so let me show you. So like 6, 5, plot the given point on the graph. So like 6, 5 says positive, positive. That would definitely be in quadrant 1. So the way you plot a point, to plot a point, you want to begin at the origin, which is 0, 0. And you want to move via the x coordinate first. Okay. So if you're moving, if your coordinate is positive, then you're going to move to the right. And if your coordinate is a negative, then you're going to move to your left. And then you're going to hold your pencil. Don't plot the point. Not yet. You don't plot a point just yet. Not yet. Because you have to move via the y coordinate. So for your y, you would find yourself moving up if you have a positive coordinate, and you would find yourself moving down if you have a negative coordinate. And then you want to plot and you want to label. Plot and label. Ordered pair. So for the 6, 5, 6, 5 is telling you that you're going to move right 6, and then you're going to move up 5. Right 6, up 5. So, and you do that from the origin. Right 6, up 5. And you can barely see the line. It came out really light. It looks like it's somewhere here. Up right 6, up 5. It's an estimate. See, but it's positive, positive. Now, if your point lives in quadrant 2, that means that the x, see the x is negative, and that means the y is positive. Okay, so I look at that, doesn't look like I have any negative positives on this one. Okay, no examples from here to show you for that. If a point lives in quadrant 3, your coordinates would be negative, see x would be negative, and y would be negative. So you have double negative, negative, negative. And that would be like C, C. So your x is -2. That tells you you're going to go left 2. And then the -7, you're going to go down 7. So from the origin, you're going to go left 2, -1, -2, hold your pencil. And you're going to go down 7. So it's really light. This looks like about right here. So out 2, -2, and then all the way down -7. And then if you have a point living in quadrant 4, that'll be positive, negative. So that looks like A, right? Looks like A, then A is 2, -1. So 2 tells you to go right 2, and then -1 tells you to go down 1. So from the origin, you go to the right 2, and then you go down 1. Okay. All right. So that's number 1, plotting your points. Okay, now 2, we really can't do 2 because the lines didn't come out. Here they give you the coordinates and they want you to identify where the coordinates are at. Let me see. My lines are really, really light. Let me see if I have something in my answer key in here. Yeah, I do have something. So like A, we're going to just estimate. A would be start of the origin. So you see you have to go right. This actually happens to be 6. And then you went down, which looks like you went down about 1 time. Down -1. Went to the right and down. So that's your A. B looks like you went to the left, out 2, and then you went up also about 2. -2, 2. C is you went from the origin, you went right 1, and then all the way up about 4, because there's 5 right there. 4. Okay, so those are all the points that were there. Okay. And then if we look at number 2, or actually, let's see, yeah, page 159. Plot the given points on the graph. Okay, so remember these are like X, Y, remember alphabetical order. X is, it's an estimate, 3 and 2500ths, 2. So this tells you you're going to go right, and then you can go up, right, and then up. So 1, 2, 3, a little bit past 3, it's about right here, and then up 2. So it's just an estimate. That's about 3.252. And -4, -2, and 5/10. So this tells you to go down. No, excuse me. You always go right or left. You always go right or left first. X, right or left. So you're going to go left because it's negative. And then you're going to go down. So left, -1, -2, -3, -4, and down 1, 2.5. -4, -2.5. That's B. That's A. Okay, and then let me give you some ordered pairs with 0. Let's say you had the point for C. Let's say you had 0, -8. X, Y, 0, -8. 0 tells you to stay. 0 tells you to stay. And then the -8 tells you to go down. So you're at the origin, 0, 0, 0 tells you to stay. And then the -8 tells you to go straight down. 5, 6, 7, -8 is right here. And then D is the 0.60. So 6, you would go right. And then you would stay because of that 0. So at the origin, you go to the right 6. And then you stay right there. Okay. So always when you always begin at the origin, and you try and move right or left, hold your pencil, and then you go up or down. Okay. Okay. Then let's go to page 160. Is this next problem here? 3. Consider the equation and the following ordered pairs: 1y and x is negative x negative 2. So 1y and x negative 2. Here's your equation. Step 1, compute the missing x and y values. So you see your table? See how sometimes this is missing y, see this is missing x? These are assigned. Here, x was assigned 1. Here, y was assigned negative 2. These are assigned. So compute the missing x and y values so that each ordered pair will satisfy the given equation. Then you see on the bottom, I want you to graph that. Okay, so for the first one, we say we're going to let x equal 1 because see that's a sign, and we're going to substitute it, and then we're going to solve for the other letter for y. So you have 3x plus 6y equals 9. And everywhere you have an x, you're going to plug in a 1. 3 times 1 plus 6y equals 9. Then you do your algebra. 3 times 1 is 3 plus 6y equals 9. And you want to solve this for y. So you want to move the 3 first. Do an opposite. 3 is minus 3. You have 6y equals, and 9 minus 3 is 6. And now you just need to divide both sides by 6. Y equals 1. So just coincidence that when x is 1, y is 1. And I'm also going to add this ordered pair here, x, y. When x is 1, y also happens to be 1. Ordered pair is an ordered pair. So this tells you to go from the origin, right 1, up 1, doesn't it? So from the origin here, out 1, up 1. So it's an estimate. And then we're going to do this again. We're going to let this time, now look, we're going to let y be negative 2. And you see it's y, see, y be negative 2. So let y be negative 2, substitute into your equation, and solve. So 3x plus 6 times y, which is negative 2, equals 9. And 6 times negative 2 is a negative 12. So I'm going to write it like that, minus 12. And you want to solve for, you're solving for x. So you're going to add 12 to both sides. Nine x, 9 and 12, 1, okay. Then we divide by 3. Seven. 3 is 21. Okay, so it looks like you're going to get 7. So you have the coordinates 7, negative 2. So this says you go to the right 7 and you go down 2. So from the origin, you go to right 7 and you go down 2. And then here, these lines are part of the equation, so you would connect those points as best as you could with a ruler. And the name of the equation is 3x plus 6y equals 9. That's what we use. These are collinear. These are collinear points. Collinear points lie on the same line. Okay, and then there's one more here. Let's see. Consider this equation. V is equal to 8 times h. So V standing for volume is equal to 8 times the height, where V is the volume in cubic centimeters of a box with a variable height, h centimeters, and a fixed base of area, 8 centimeters squared. So yeah, area is units squared. So complete this table. So here they gave you all the h's this time, all the h's, and they want you to find the v's. And if you look at your table, you know, it's talked about independent and dependent variable. So this is the h is the independent variable. Independent, whereas the y is dependent variable, the v. Okay, there's your 0, 0, 0. Okay, so there's your h. Okay, so when h is 2, we're going to let h be 2. We're going to sub into the equation. V is equal to 8 times h. And everywhere you have an h, we're going to plug in 2. Because it says let h equal 2. And 8 times 2 is 16. So when h is 2 and you plug it into the equation, you get 16. So we have the ordered pair HB 2, 16. So when you plot that, you go to the right 2 and then straight up 16. To the right 2 and then straight up to 16. And then when you let h be 3 and then you sub b is equal to 8 times h, h is 3, and you see 8 times 3 is 24. And so when you're substituting 3, you get 24. So you have 3, 24. So go to right and then you go up. Go to the right 3 and then go all the way up. 324. Through any 2 points, you can always draw a line, and that's why they would like you to do like 3 or 4 points. So let's let h equal 4 now, and you're going to substitute it. So you have b is equal to 8 times h, and h is 4 right here. And that gives you 32. So you have 432. So you can go to the right and then go up. To the right, 4, and then up. So when you plot it, we said you were to go 432. So let's see, this one looks off. So first we did 216, which is this one. Oh yeah, 216, which is this one. And then we did 324. What's that? And now 432. And then 7. H equals 7. B equals 8H. And we're substituting. V is 8 times H, and you will H be 7, which is 56. And $56. H was in height in centimeters, so those heights were in centimeters. That's 7 centimeters. 8 times 7. So those are all centimeters, it looks like. These are all centimeters, in case you're wondering. And this is the point 756. You would go to the right and then go up. So 7 to the right and then go up. Right here. And then it should be somewhat collinear when you're done. You should kind of give a straight line. It might be off a little bit because the lines are hard to see because they're really light. So it kind of throws this point off a little bit. Okay, and the name of that is V equals 8 times H. Okay. So you see how we're substituting points and then plugging them in, substituting, plugging them in, kicking out values for V. And then you're making an ordered pair. This is an ordered pair. And then you're plotting them. Okay. All right. Let's see. And then if we do, these are some of the ones from the workbook. Let's see, exercises. Let's see, some of the true or false. Let's see what they say. It says that the graph of every ordered pair that has a positive x coordinate and a negative y coordinate can be found in quadrant 4. So let's see. So quadrant 4, here's quadrant 1, quadrant 2, quadrant 3, quadrant 4. So they want quadrant 4, which is right here, this would be, see, positive, positive, and then negative, positive, negative. So the graph of every ordered pair that has positive x coordinate and a negative y coordinate, yeah, so it's the x and then y, can be found in quadrant 4. Yeah, so I agree with that. That's true. Okay, that's for this quadrant right here. To find the y value that corresponds with x equals 2, substitute 2 for x into the given equation, and then you would solve for y. Yeah, and they're saying that's true. We were trying to find the y value. Yeah, so you would start substituting x equals 2 into that equation. It should be just fine. If negative 7, 3 is a solution to this equation, then negative 7, 3 satisfies this equation. They're saying that that's true. So probably what I would do is, if negative 7, 3 is a solution to this, then negative 7, 3 satisfies this. Yeah, and they're saying that's true. Yeah, and so I could, if I plug that in, this is x and y. So y is 3. 3 times x is negative 7 plus 24. We put a little question mark here. 3 equals 3 times negative 7 is negative 21 plus 24. Yeah, and so you have 3 equals to 3. That's true. Yeah. Okay, so yeah, it satisfies that. And number 4, if point A, which is 0, 4, if point A, then point A lies on the x-axis. Point A is 0, 4. So like where is that? Like do a generic x, y, 0, 4. Don't go right, don't go left. So 0 tells you to stay, and then the 4 tells you to go up. So you don't go right, you don't go left, you stay and you go up. 1, 2, 3, 4. You stay there. 0, 4, that's the point. 0, 4. If point A, which is 0, 4, if A equals this, then point A lies on the x-axis. No, it looks, that's false. It looks like it lies on the y-axis. So it is false, and it says y-axis. That's true, it lives on the y-axis. See the picture? Okay. And then if we do, like, let's look at 7. This is on page 152. Determine the missing coordinates in each of the ordered pairs so that the point will satisfy the given equation. So they have here A is 0, and you have this equation. So this 0 is the x, because it's x, y. So they're letting x be 0, and they're going to substitute. They have 0 take away 2y equals 2. So negative 2y equals 2, and now divide by negative 2, and y equals negative 1. 0, negative 1. Okay. And if I do d, x, y, here you're letting y be 3, and you're going to sub. And you have your equation x minus 2y equals 2. And everywhere you have a y, you're plugging in 3. So x minus 6 equals 2. You're going to solve that for x. You should add 6 to both sides. And 6 and 2 is 8. See, that's what this is the answer key. 8, 3. That's correct. X equals 8. Okay. And the last one we'll do is number 8. Complete the table so that each ordered pair will satisfy the given equation. Plot the resulting sets of ordered pairs. Okay, so they're saying, okay, here they want you to plug in x is 0, okay, and then find out what you get for y. So y equals 2 times x minus 3. Y equals 2 times 0 minus 3. Y equals minus 3. Okay. Here they want you to let y equal -1. If y equals 2x minus 3, everywhere you have a y, you plug in -1. Okay, then I'm going to solve this for x. So you have to add 3 to both sides. This falls out. This equals 2x. 3 and the -1 is 2. And now to solve that, you're going to divide both sides by 2. And x equals 1. So when x equals 1, when you let y be -1. And then now you're going to let x equal -2. So y equals 2 times x, which is -2 minus 3. That's a -4 minus 3. That's a -4 plus -3, which is -7. And then now you're going to let y equal 3. Y equals 2x minus 3. And everywhere you have a y, you're going to plug in 3. 3 equals 2x minus 3. And you have to solve that for x. So you have to add 3 to both sides. These fall out. 3 and 3 is 6 equals 2x. In math, you undo times by some divisions. You divide by 2. And 6 divided by 2 is 3. So it looks like you get 3, 3. And these I can check 0, -3, -1, -2, -7, and 3. So these I'll check out. And then this is the graph for that. So I remember I have an answer key. So 0, -3, this tells you to stay, and then you go down. When you stay, you go down. That's this right here. 0, -3. 1, -1 tells you to go to the right and then go down. So go to the right and then you go down. So that's this point right here. 1, -1. -2, -7 means you go to the left and then you go down. So go to the left, -2, and then go all the way down. -2, -7. And then 3, 3 means you go to the right and then you go up. To the right and you go up. 3, 3. And then when you're done, this is supposed to be the points for that line. And it should look pretty collinear. It's for y equals 2x minus 3. So here we're graphing using a table, using a table here. Okay. sometimes when I do my tables, like I'll make like when we do the next section, I usually do my tables like this: y equals 2x minus 3, y, x, y. So you'd see on my practice, if you look at your practice test templates, I usually have that like that. So we let x be 0. So we let x be 0 and you sub. So y equals 2 times 0 minus 3. Anything times 0 is 0 minus 3. Y equals minus 3. Minus 3. This is 0 minus 3, which means you stay and then you go down. So you see that work, I did it here outside of a table. But usually when I do 10.2, I'll have these tables, I'll build these tables. And I put all my algebra in here. Here's my equation. When x is 0, I substitute algebra here and I kick out a -3, and then I have 0, -3. Whereas here I was just doing them all kind of separate, scattered all over the place, and then filling in the table here. This is all organized in one location, and then we graph it 0, and then we'll stay and go down 3. So those are my notes for 10.1. I hope that helps.